The continent of Africa splitting into two.
Which is wider, and other sections which are so deep you cannot see the bottom.
Africa, the world's second largest continent, is undergoing a dramatic transformation right beneath our feet, and most people have no idea. In the distant future, what we now know as Africa could be two separate continents. Geologists have discovered that a colossal rift is slowly tearing the continent apart. The process is subtle, but the implications are massive. What's causing this shift, and how will it reshape the world as we know it? Let's dive into the fascinating science behind Africa's hidden geological split. In 2005, an incredible change occurred in East Africa, with amazing images and reports revealing the emergence of a continental rift, showcasing a geological phenomenon. This amazing event is characterized by the continent seeming to split and separate into two or more separate parts. The ongoing rifts and relentless movement of tectonic plates have been crucial in forming our world, as every continent on Earth is a result of this natural process. In order to fully understand the amazing events happening in Africa, we need to go back hundreds of millions of years to when Earth was a single landmass surrounded by water. During that particular time in Earth's past, it was called Pangaea, the only supercontinent, and the sea surrounding it was named Panthalassa. In the ages that came after, our world experienced a remarkable transformation. For countless years, the Earth's crust has undergone a continuous process of heating, cooling, fracturing, and coming back together to form the diverse mosaic we see today. This grand process fuels the formation of continents, islands, oceans, and seas, representing a captivating stage in Earth's continuous development that is truly inspirational. Even though our planet may seem calm on the surface, there is actually a world of continuous movement and transformation below, similar to a living organism. The Earth's lithosphere, which is the solid ground we walk on every day, is the fundamental aspect of this geological wonder. This lithosphere, made up of around 15 to 20 huge tectonic plates, directs the majestic dance of our planet's continents. These plates are responsible for the design of continents and islands, shaping their unique forms and impacting the movement of our planet's landscapes. During this complex geological process, tectonic plates converge and diverge, resembling puzzle pieces fitting into their correct positions. This continuous interaction is what shapes Earth's surface, forming mountains, valleys, and rifts. Continental fractures, like the ongoing one in East Africa, are a result of continuous movements where a continent is slowly but steadily splitting apart. When considering Earth's tectonic plates, imagine large fragmented puzzle pieces floating above the extremely hot molten layer beneath our planet. These puzzle pieces continuously move in a graceful dance known as plate motion or tectonic shift. When examining the map of our planet, you may observe an interesting similarity. The curved coastline of South America and the corresponding shape of Africa appear to have once been connected, resembling pieces of a puzzle fitting together. It is no accident. In the past, these continents were once a single large landmass. It was surprising how the continents and oceans formed due to a massive breakup that divided the supercontinent into smaller fragments. Currently, as indicated by NASA's Earth Observatory, Africa is undergoing subtle changes. The plate from Somalia in the east is attempting to separate from the large Nubian plate, which has been part of Africa for an extended period. At times, the Somalian plate is referred to as the Somali plate, and the Nubian plate is also known as the African plate. Always in motion, these plates are not only drifting apart from one another, but also from the Arabian plate to the north. This massive division takes place in Ethiopia, specifically in a location known as the Afar region. Geologists see this region as a Y-shaped fissure where the Earth's outer layer expands and forms a fresh sea. The East African Rift is named by the significant Geological Society of London. The East African Rift resembles a vast system of valleys extending 2,175 miles from the Red Sea to Mozambique. This lengthy process gradually transforms our planet, resembling a tale from antiquity. If the Somalian plate successfully separates from the Nubian plate, Earth's second largest continent will be divided into two separate sections. This would be a geologist's dream and a marvel for scientists, similar to the separation of South America and Africa in the distant past. However, this significant shift will not happen rapidly, as researchers estimate it will require a substantial 5 to 10 million years for the Somalian plate to completely break away from the Nubian plate. An imminent seismic shift, a major event in geological history, may occur in the Earth's crust soon. Geologists and scientists are interested in the separation of the Somalian plate from its longtime neighbor, the Nubian plate. Nonetheless, this impressive change may not stick to one expected course, presenting numerous intriguing opportunities. One intriguing possibility envisions the sudden separation of a large part of the Somalian plate from the African continent. This partial division may result in the emergence of a new body of water between the two pieces of land. This fresh body of water would not just encompass Somalia, but also stretch into Eritrea, Djibouti, and portions of Ethiopia, Kenya, Tanzania, and Mozambique. The consequences of this territorial change would be massive. However, in addition to this ambitious idea of a large ocean, there is also a smaller potential option. Only the eastern parts of Tanzania and Mozambique would break away from the African continent in this situation. Despite being on a smaller level, this particular division would still result in major outcomes. The impact of these geological events could be especially significant for countries without coastline access. Ethiopia and Uganda, both traditionally landlocked nations, would see significant advantages from acquiring a new coastal area. This advancement would enhance their economies by creating fresh possibilities for trade and manufacturing. In a study, it is said that the Gulf of Aden and the Red Sea will merge into the Afar region, gradually creating a new ocean in the East African Rift Valley. Consequently, this area of East Africa will change into a unique and individual landmass. The consequences of this change are remarkable. Even though the advancement of the division is apparent, it is also gradual. Geologists believe it grows at a rate of 0.25 inches per year, similar to the slow development of toenails. This remarkable process takes time to unveil, needing patience and reflection along the way. Geologists and geophysicists remain intrigued by the creation of rifts, leading to ongoing discussions in the scientific community. One prominent explanation proposes that the primary reason for rifting is a rise in heat flow coming from the Earth's depths. This rise in temperature results in thermal bulges, which are evident in regions such as central Kenya and the Afar area of north-central Ethiopia. When observed on topographic charts, these protrusions manifest as elevated terrains that gradually alter the Earth's crust during their formation. A lot of geologists and geophysicists think that thermal bulges are primarily caused by mantle plumes, which are hot magma columns that rise from deep within the Earth. A mantle plume is a region below the Earth's crust where magma is significantly hotter compared to the surrounding magma. The intense heat gradually melts and thins the crust above, leading to the expansion and fracturing of the land. The thermal bulge expansion frequently results in substantial volcanic activity on the Earth's surface right above the plume. It is a stunning view, like the Earth is pulsating with life. Massive volcanic eruptions often occur following the stretching of these thermal bulges, demonstrating a noticeable trend. Geologists refer to these volcanic eruptions occurring on rift edges as flood basalts. In contrast to regular volcanic eruptions from a single volcano, flood basalts erupt through fractures within the bulges. Molten lava cascades across the terrain like a river, forming a captivating and impressive sight. The immense size of these volcanic eruptions is astonishing, encompassing extensive areas and altering the geological composition of the land they come into contact. Standing on the brink of one of these crevices provides a view of a natural phenomenon that is difficult to understand. The Earth's outer layer starts to elongate and move due to the extreme heat from the mantle plume underneath. Over time, the thermal bulges form through a process of expanding and fracturing, transforming familiar landscapes into high elevated areas. These uplands signify the initial phases of a significant geological change, acting as a symbol of the massive forces operating below ground. As the thermal bulges keep expanding, they set the scene for one of the most spectacular events in nature. Increased temperatures and pressures in the Earth's mantle force magma to rise to the surface via cracks in the ground. The outcome is a breathtaking volcanic explosion. In contrast to regular volcanoes releasing molten rock from a central point, flood basalts flow out along fault lines caused by the bulges. The eruption of lava resembles a swollen river rushing over the terrain, altering the landscape with every flowing stream of molten rock. The process involves potent and slow changes to the Earth's surface through rifting and volcanic activity, showing the ongoing movement and transformation occurring beneath us. Every volcanic explosion changes the terrain, providing insight into the powerful geological processes that influence our planet. The continuous geological shifts in Africa bring attention to a prominent characteristic called the Rift Valley. This interesting geological feature is a flat region formed by the shifting of tectonic plates. As these huge plates gradually move away from each other, they create amazing rift valleys. These extraordinary formations can be found on both solid ground and below the surface of the ocean. Let's examine in more detail the formation of these rift valleys and the insights they provide into the dynamic characteristics of the Earth. On land, rift valleys form as tectonic plates separate, unveiling a distinct terrain. Unlike river or glacial valleys, which are created by erosion, rift valleys are formed by the direct splitting of tectonic plates. This procedure acts as a recollection of the perpetual movement of the Earth below ground. It's like the Earth is exposing its hidden truths by showing these fissures in the terrain. A captivating characteristic of rift valleys is their formation at locations known as triple junctions, according to geologists. These locations are where three tectonic plates intersect at approximately 120-degree angles. When this happens, typically two plates move apart from the third one, resulting in the formation of a new ocean, a process similar to the birth of something significant. The third part, nonetheless, remains connected, referred to as a failed rift or allocogen. This incomplete division eventually evolves into a rift valley. These unsuccessful separations contribute an intriguing section to the geological narrative, proving that unfinished processes can still form impressive geographic features. An evident illustration of this phenomenon is the creation of the Atlantic Ocean. It started at a point where three things met in the current Gulf of Guinea on Africa's west coast. Two parts of the ancient supercontinent Pangaea separated, leading to the formation of the Atlantic Ocean. In the meantime, the third branch of the intersection, the unsuccessful rift, did not turn into a sea but transformed into the Benue Trough, a beautiful rift valley located in southern Nigeria. This geological marvel is a symbol of how Earth's history and landscape are intertwined. However, rift valleys can be found beyond the Earth's surface. Below the seas, the same activities persist in forming the Earth's geological structure. These submarine chasms develop beside extensive chains of mountains called mid-ocean ridges, which act as boundaries separating tectonic plates. When the plates separate, magma from the Earth's mantle comes up to fill the empty space. When the hot magma touches cold seawater, it cools and creates fresh oceanic crust, contributing to the constantly shifting ocean floor. This process underwater is equally as stunning as its on-land equivalent. It resembles a tango of tectonic plates, elegantly moving away from each other like dancers on a big stage. These underwater mountain ranges extend across vast distances beneath the ocean, indicating where the Earth is constantly generating fresh crust. Over time, new geological formations are created by these underwater ridges, contributing to the ever-changing nature of our planet. The East African Rift Valley demonstrates how these geological processes occur on land. This system of rift, extending from the Red Sea to Mozambique, demonstrates the slow division of the African continent. While the Nubian and Somalian plates continue to separate, they form a lengthy, shallow valley that suggests the potential for a forthcoming sea. If the process persists for millions of years, a new sea may be created, ultimately separating Eastern Africa from the rest of the continent. This continuous division gives insight into the gradual changes of landscapes. Despite occurring at a slow pace of only a few millimeters annually, these changes are significant influences molding the Earth. The Rift Valley shows how the Earth is always changing, with tectonic plates moving, crashing into each other, and moving away. These processes serve as a reminder that the supposedly stable surface beneath our feet is constantly shifting, forming fresh terrains and geological characteristics. Rift valleys, whether on land or underwater, demonstrate the Earth's ever-changing nature. They demonstrate the creation of continents, the opening of oceans, and the rising of mountains throughout millions of years. These geological characteristics are more than just surface fractures. They provide a glimpse into the strong influences responsible for forming our planet. Every rift valley, such as the Benue Trough, which is unsuccessful, or a large mid-ocean ridge, shares a tale of change. By observing these structures, we can see the Earth's history, current state, and future evolving gradually yet impressively. A gradual geological process is occurring in the expansive northern section of the mid-Atlantic ridge. The huge North American plate and the giant Eurasian plate are gradually drifting apart in this location. This process occurs gradually, at a pace of approximately 1 inch per year. Despite its seemingly small scale, this movement has formed remarkable rift valleys on Earth over a period of tens of millions of years. Underwater, rift valleys are massive canyons that can span up to 9 miles wide. Another instance of this process can be observed along the East Pacific Rise in the Pacific Ocean. In this location, the Pacific Plate separates from the North American Plate, as well as the Cocos Plate, the Nazca Plate, and the Antarctic Plate. These oceanic fissures contain a remarkable mystery: hot springs on the seafloor. These openings, similar to nature's secret chimneys, emit hot water and mineral-rich fluids into the ocean, revealing the intense geological activity occurring under the water's surface. In East Africa, on the opposite side of the world, the Great Rift Valley forms as another impressive geological feature. This rift valley is renowned as one of the most well-known on the planet. It extends from the north of the Middle East to the south of Mozambique. This extraordinary geological formation contains numerous marvels of nature: active volcanoes, calming hot springs, captivating geysers, and occasional earthquakes serve as reminders of the underground forces at play. This gradual but continual shifting of tectonic plates, whether under the sea or on continents, molds the Earth in ways that are both stunning and forceful. The fantastic characteristics of the East African Rift are displayed in two primary divisions: the Western Rift and the Gregory Rift. These valleys are adorned with remarkable volcanoes, each displaying Earth's turbulent past. The area showcases Earth's impressive geological history, from Ethiopia's fiery Erta El volcano to Kenya's majestic Mount Kenya. One of these volcanic marvels is Oldoinyo Lengai in Tanzania, a sleeping stratovolcano that showcases nature's peaceful power. Another massive stratovolcano, Mount Kilimanjaro in Tanzania, looms tall as a dormant giant overlooking the Western Rift. In the Democratic Republic of Congo, Mount Nyiragongo stands tall as an enigmatic and formidable presence, serving as a constant reminder of the ongoing geological activity beneath the Earth's surface. The Western Rift, also called the Albertine Rift or Lake Albert Rift, provides access to the East African Great Lakes. This region, abundant in biodiversity, contains snow-covered peaks, vast grasslands, and old mountain forests. Unique bodies of water mirror the evolving beauty of the scenery, enhancing the enchantment of this area. Named after the geologist who surveyed it, stretching from the Red Sea to the Arabian Sea, the Gregory Rift descends to meet Mount Kilimanjaro. The Afar Triple Junction is one of its most remarkable attributes. This geological meeting point connects the Horn of Africa to the Red Sea and the Gulf of Aden. In this area, the Arabian Plate, the Nubian Plate, and the Somali Plate slowly and continuously separate from each other in a coordinated movement. During their separation, the Earth's crust widens due to seafloor spreading. One arm stretches into the Red Sea, while another spreads into the Gulf of Aden. A fascinating idea arises. If the Gregory Rift keeps expanding, it may eventually submerge under the Arabian Sea. Should this occur, the Horn of Africa could separate from the continent, becoming a distinct island similar to Madagascar or New Zealand. This significant transformation would signify a fresh beginning in the Earth's geological history, and people worldwide would be amazed by the formation of this continent. While both the Western and Gregory branches of the East African Rift stem from the same source, they possess distinct and impressive characteristics. The Gregory Rift is characterized by volcanic activity, highlighting Earth's fiery nature, whereas the Western Rift is famous for its deep basins and expansive lakes containing fertile sediments. In the center of the Gregory Rift, volcanic eruptions captivate scientists with their powerful explosions. Volcanoes in this area behave as restless giants, shooting lava and ash into the air. The Earth's inner vibrations cause the ground to shake. These volcanic eruptions give scientists the opportunity to observe the Earth's internal processes in action. On the other hand, the Western Rift provides a serene environment with expansive deep basins and tranquil lakes scattered throughout the area. Lake Tanganyika is located within this geological marvel and is the second deepest lake in the world. Both biologists and explorers are drawn to the rare species and ecological treasures found in the enigmatic depths. Close by, the beauty of the area is enhanced by Lake Malawi's basaltic eruptions and active crevices, creating a unique contrast to the tranquil waters that surround it. The East African Rift is a geological enigma, offering scientists a unique opportunity to witness the creation of ocean basins on land. In various regions around the globe, fissures have either developed fully and been covered by sediments or sunken below the sea. Nevertheless, the East African Rift remains active, demonstrating ongoing geological transformation. It can be compared to a constantly changing textbook, with Earth's lithospheric plates in the process of creating something fresh. Rift lakes, a characteristic feature of rift valleys around the world, beautify this area. These lakes are created as water gradually fills rift valleys. A historical illustration of this procedure can be observed in North America. Over 1 billion years in the past, a deep rift valley was created when the continent started to split apart, forming a triple junction. As time passed, this valley was filled by streams, rain, and rivers, resulting in the creation of Lake Superior, which is among the world's oldest and deepest rift lakes. Nevertheless, nature's intentions are always unpredictable. Millions of years later, the rift in North America slowed down, allowing the continent's landmasses to remain connected and preventing the creation of a new ocean. Today, Lake Superior is located on one of the oldest rift valleys, serving as a symbol of the ongoing battle between creation and change on Earth. Situated in the magnificent Bull Rift Valley in Siberia, Lake Baikal is not just a body of water, but also a remarkable work of nature. Lake Baikal, recognized as the world's deepest and oldest freshwater lake, captures interest due to its numerous enigmas, with every stratum showcasing the progression of time. Diving down into Lake Baikal reveals a deep chasm that plunges 5,387 feet below the surface of the Earth. This impressive trench has been created by tectonic forces over 25 million years, shaping the Bull Rift Valley and gradually depositing layers of soft sediments at the bottom of the lake. The factual base of the Rift Valley surpasses 3 miles, displaying an almost inconceivable geological depth. Yet, Lake Baikal is more than just its remarkable depth. It is also the world's biggest freshwater lake in terms of volume, holding approximately 5,700 cubic miles of pristine water. Picture this expansive body of water brimming with creatures and mysteries, situated amidst the harsh terrain of Siberia. Lake Baikal is considered the most important rift lake, while the Dead Sea, situated in the Jordan Rift Valley, has a different geological narrative. Even though the Dead Sea is not the deepest lake, it is distinguished as being the lowest point of land on Earth, lying 1,410 feet below sea level. The lake's surface forms an odd basin, while below its haunting beauty, it plunges to depths of around 1,997 feet. Nevertheless, it is crucial to acknowledge that the Dead Sea does not fit the criteria of a genuine rift lake. In contrast to Lake Baikal, the Dead Sea is not located above a completely developed rift. Rather, it is located on the Dead Sea Transform, a complicated geological area with intricate movement of tectonic plates. In this place, the Earth's crust moves and trembles, forming an ever-changing terrain. In this geological stage, the Earth's ancient drama plays out. The Bull Rift Valley narrates a magnificent story at a leisurely pace as the Earth's crust is pulled and stressed, leading to the creation of the astonishing Lake Baikal, which is both the deepest and oldest freshwater lake. In the meantime, the Dead Sea Transform acts as a platform for the Earth's erratic powers as tectonic plates collide and shift, leading to the distinctive and enigmatic terrain of the Dead Sea. The Rift Valley Lakes, located in the expansive East African Rift, are among the most renowned natural wonders globally. This series of stunning lakes extends elegantly through the African terrain, from the scenic mountains of Ethiopia to the inviting coastlines of Malawi. Freshwater lakes such as the renowned Lake Baikal coexist with their saltwater equivalents, like the well-known Dead Sea. Together, they form a varied range of water environments that impress with their amazing variety of life forms. Lake Tanganyika, a valuable addition to the Rift Valley's assortment, borders Burundi, the Democratic Republic of Congo, Tanzania, and Zambia. This vast expanse of water provides a safe haven for numerous distinct fish types that cannot be found anywhere else on Earth. These fish have adjusted and developed in the tranquil waters of Lake Tanganyika, creating an intricate network of life below the water's surface. Journeying southwards to Tanzania, you will encounter the captivating Lake Natron, a shallow soda lake that mesmerizes with its vibrant red hue. The vibrant color is caused by bacteria that prefer salty environments rather than by the rocks themselves. It is a stunning view, a real showcase of nature's creativity. In the southern direction, Lake Malawi, also called Lake Nyasa, rests elegantly in the western section of the East African Rift Valley. This shimmering body of water is the third deepest lake with fresh water globally and supports a vibrant ecosystem. Nevertheless, it encounters significant obstacles due to waterborne illnesses. In spite of these challenges, Lake Malawi houses an impressive 800 to 1,000 fish species, establishing itself as the top contender in global fish diversity. The East African Rift is causing the gradual division of the African continent, prompting interest from geologists, ecologists, and government officials. The study and analysis of this area has become crucial, greatly deepening our knowledge of human evolution. Numerous respected experts argue that the intricate development and progression of the East African Rift were essential in establishing an environment suitable for the thriving of life. Furthermore, the presence of this geological rift has increased East Africa's susceptibility to climate change. This heightened sensitivity has resulted in a continuous cycle of wet and dry seasons, causing significant environmental challenges for our ancestors as they adjusted to shifting climates. These circumstances prompted our early human ancestors to stand on two legs and grow bigger brains, representing important advancements in the evolution of humans. The East African Rift System consists of a complicated network of rift segments that provide valuable information on continental separation and ocean creation. Nevertheless, its importance extends beyond just geological curiosity. The East African Rift Valley has the capability to produce energy because of the significant volcanic and tectonic events taking place in the region. This live geological hotspot has the potential to be a major energy provider in the coming years. The East African Rift is significant for learning about human evolution and geological processes, as well as being a promising area for energy resources. The continuous geological processes and weather difficulties have influenced the direction of human history, displaying the complex connection between the environment and evolution. The gap continues to be a central area of focus for research and exploration, underscoring its significance in various fields of study. At the moment, the United Nations Environment Programme is participating in a cutting-edge geothermal energy initiative. This crucial initiative focuses on harnessing the Earth's subsurface natural energy in the East African Rift Valley. The project aims to harness the heat generated by the underground processes in the Rift Valley to generate electricity using a system of steam wells. Each well has the capacity to provide electricity for approximately 5,700 households. If successful, this ambitious project could provide sustainable energy to countless individuals who currently lack access to electricity. Yet similar to numerous tales of advancement, obstacles exist. The volcanic and tectonic forces present both opportunities for energy and dangers for the residents of this area. The increasing water levels are a significant worry, underscoring the challenges encountered by East African Rift Valley residents. Moreover, the finding of oil deposits close to a lake in the same rift adds complexity to the issue, leading to concerns about the allocation of Africa's territory and the risk of disputes over natural resources. Severe malnutrition and widespread poverty have a significant impact on the local population's daily lives. The excitement and hope of scientists sharply contrasts with the unpredictability of an active rift characterized by volcanic and tectonic changes. It is unclear if Africa will divide into two or more landmasses soon, but what is certain is that the East African Rift will have a major impact on our future in the years and centuries ahead. This geological marvel, with its possibility for both opportunity and risk, is essential to the continuing narrative of humanity's advancement.